right, so this is called do now day 7, right? Do now day 7, here we go. So you want to say today reported that the speed skater Bonnie Blair had won America's Heart on the USA Today 194 Olympics. She was considered the hero of the Olympics. 65% of the respondents chose Blair. What's that? That's P hat. That's the sample proportion of people who felt that Bonnie Blair was the hero. The poll of 615 adults, what's that? And the sample size was done by phone. So we could actually calculate the X value of that if we wanted to. It would have been out of 615. We would have multiplied 615 by 0.65 if we wanted to. It said the margin of error was 4%. So we have to make that a decimal. Margin of error, or ME, equals plus or minus 0.04. Let's see. Which of the following statements best describes what is meant by a 4% margin of error? So what does it mean to have a 4% margin of error? Visualize what the margin of error is. It's that distance around the p hat. So remember, you put your p hat in the middle, and you're adding and subtracting by 0.04. But think about what your goal is with that. Okay, so read them over, and then tell me what you got. So the answer is E, and it has to do with, you want to try to capture the true parameter piece. And you know it's going to lie somewhere between here and here, or between here and here. So that difference, that distance between here and there, the endpoint, is that full margin of error. And you basically want to try to capture that true proportion within that distance. There you go. Good job. Okay, so now this question we actually don't know how to do fully yet, but we're going to set it up and then I'm going to explain. Okay? A 95% confidence interval for the proportion will be used. So everyone will circle 95%. That's called the confidence level. We have to get the Z star from that. So immediately I want you to find Z star for 95% level. But you guys probably already know it by heart. What is it? Well, it's 1.96. Very good. That's stable B. Remember, tomorrow you can use your reference statement. All right, so P hat plus or minus E for error. So remember, the confidence interval is statistic plus or minus critical value times the standard error of the statistic. It says, which of the following is the smallest sample size? That's N, right? They're asking me about the smallest N that will guarantee a margin of error of at most 0.08. So what inequality symbol do we use for margin of error to be at most 0.08 or 8 percentage points? Less than or equal to. So we want to write wants margin of error to be within 8 percentage points, essentially. Okay. Now the margin of error is this piece that comes after the plus minus. So we're basically going to set up an equation or an inequality where we're setting our margin of error to be less than or equal to 0.08. Now, what is the margin of error comprised of? It's comprised of the critical value, which is P star, times the standard error of the statistic, which is P hat. So we're going to do the standard error of P hat, right? And we're going to set that to be less than or equal to 0.08. And we're going to plug in whatever we. So I'm going to just fill in the blank here. Maybe put this up a little bit. So I'm going to do Z star times the square root of, what's the formula for standard error of P hat? P hat 1 minus P hat over N. And then we're going to set that to be less than or equal to 0.08. And now we're going to plug in what we know. All right, we're going to create an inequality equation. So we know the Z star, right? That's kind of all we know, sadly. So we know Z star is 1.96. We don't know P hat. We don't know Q hat. We don't know. And we know the margin of error on the right-hand side of this inequality is 0.08. all right? So we know that we're solving for the sample size n. That's the unknown in the denominator. Definitely know that. But what's up with p hat? So you guys remember, if you have p, you use p hat, and then it's called standard deviation, not standard error. If you don't have p, you use p hat in its place, and then it's called standard error. But what if you don't have p? Look up again. You don't have p. You don't have p. You don't have p hat. What do you do, right? So basically, what you have to use is something that we call p star. P star is a conservative estimate for your p hat when you don't have p hat or p. Here's 0.5, and I'm going to explain that. So I want you to think about if you put 0.5 here, the complement of 0.5 is 0.5. The largest possible product that you will ever obtain when you multiply something times its complement will be this, which is 0.5 times 0.5, 0.25. You're never going to get a bigger margin of error than that because, in the numerator of your radical basis, because let's say you had 0.6, the complement would be 0.4. 0.6 times 0.4 is let me show you some combinations of this. 0.6 times 0.4 is 0.24, right? That's less than 0.25. 0.9, the complement would be 0.1. That's going to be 0.09. 0.7, or even if you did 0.3 first, the complement will be 0.7. You're going to get 0.21. So basically, the largest possible margin of error that you will ever obtain is going to be 0.5 times 0.5, which is 0.25. And that is basically overestimating the width of the interval. You're basically like overshooting it to make it wider. And making it wider is making you more confident that the interval will contain your parameter you want to capture. So we're kind of like overcompensating here, is what I'm trying to say. And they call this a conservative estimate. So I just want to like explain what I just said here. It's basically like overshooting the margin of error, making it bigger than it really needs to be because we don't actually know the true value of the p or the p hat or just use it. So summing it up, if you have p, you use p. If you don't have p, you use p hat in this place. Second best. If you have either of those, use 0.5. Yep. If we plug in the choices, we will really get, it's actually really not that bad because it's a multiple choice question. Okay? So I'm going to show you the plug in the choices method first, and then I'm going to show you the solving method next. I do want to mention that, remember, the bigger the sample size, the smaller the margin of error, the more that the value would be likely to be within that interval. So keep that in mind. It says they want the smallest possible sample size to make this true. All right. So everyone go to your calculator screen. First, we're going to try the plug-in method. You're going to put in 1.96, which is the z star, times square root, fraction, numerator denominator, 0.5 times 0.5, which is really just 0.25, over n. So my first choice is the smallest sample size. So I'm going to start with choice A, which is 25. You know it's not good. You want to see if it's less than or equal to 0.08. When you hit enter, do you guys see it's not less than 0.08? So it's not choice A. So I'm going to cross it out. Now I'm going to plug in choice B, plug it in for n. So you guys, the nice thing is you could just hit up, hit enter, reselect the last entry, and then type over the 25, typing in 100x, and seeing what you get. You see it's not quite less than 0.08? Close, but no cigar, right? That's what they say. Next one, plug in 175. Why did they say that? Good question. Look it up. 175. Is this one less than 0.08? Yes. Okay, so this is the answer. We're going to choose it. We're not going to go any further with the plug-in method. So it's kind of nice. If you're someone who's not good at algebra, you may want to choose this method because it's easier and it's multiple choice. And often this is a multiple choice question. What is the other method, you ask? Well, it's good old-fashioned algebra. So we're 1.96 radical 0.5 times 0.5 over n less than or equal to 0.08. We're going to solve for n. So what should I do first to solve for n? Isolate the radical right now. Divide first by 1.96 to get the radical by itself. I'm going to rewrite this 0.5 times 0.5 as 0.25. Same time. And I'm just going to write this on this side. I kind of am leaving it as an exact value so that I don't count anything here. So you guys are all good. I divided out the 1.96 and I multiplied 0.5 times 0.5. Now, how am I going to get rid of the radical? How do I get rid of the square root? Yeah, square both sides. Remember, what you do to one side, you do to the other to keep it balanced. So now you're going to get rid of the radical. You're just going to have 0.25 over n is less than or equal to this thing. Now, if you want, you can put this in the calculator and see what we're working with. And then I do want to mention that we have kind of like the cross multiplication situation coming up, okay? So I'm going to show you what this equals. I'm not going to round. I'm going to write out a pretty long decimal here. So I have 0.08 divided by 1.96, hit enter, then just square that last entry. So hit square the last answer, and you get this. I'm going to write this out for you so you can see what's going to happen next. Like 00166, like 0017, like 0017. Okay. All right. So do you see how we have n in the denominator here? Now I would do what? What do you recommend? Yeah, I'm going to multiply both sides by n. I still kind of want to maintain the order of the inequality sign, so I'm not going to like cross multiply totally because then you might get confused by the order. So now that n basically is going to go on the right-hand side. So 0.25 is less than or equal to 0.0017n. And then what am I going to do? Divide by 0.0017. Okay, bring down the n. And at this point, I'm going to put this in the calculator. 0.25 divided by that last entry. So it happens to still be there. So I'm just going to do 0.25 divided by that last entry. Enter. I got 150-ish. 150.06. Okay. Now, if you look at it from this perspective, from left to right, it says 150.06 is less than or equal to n. But if you look at it from n's perspective, that actually means n is greater than or equal to 150. Okay? So this is saying pick a sample size bigger than 150. Pick the biggest sample size in the choices. Pick the first sample size, the smallest sample size that's bigger than 150. So look at the choices. What is the first sample size that is bigger than 150? 175. And that is indeed the answer. Now, some of you are good at math and you're good at algebra, then you might want to do this. This might be quicker for you than plugging in answers. Some of you are just going to plug in the answers and that's going to be quicker for you. Do what works for you, they go for it. The problem is, what if it's a free response? Then you can't plug in the answers, right? So just keep that in mind. And you know, for me, I would give you this as a multiple choice on the test. Okay, so now I want you to go back to your notes from yesterday. That is basically what this says on the notes from yesterday. I think this is called day 5, choosing, what was it called? Day 5, margin of error given the sample size or something, solving for n. Wasn't it called solving for n given the margin of error? I think we did the first piece, right, yesterday. So this is just showing you the setup of the margin of error, which is the critical value times the standard error of the statistic. And it's showing you have to set it to be less than or equal to the margin of error. And look, here's on the bottom, the star and the highlighter. It's saying if we don't know P or P hat, you're going to use 0.5 in this spot right here. All right? That's the key. So you guys are going to try the next one. Go to this one. If you get done with this one, we're going to put it up. If you get done with this one, go to this one. Okay? And you can work together. Good luck.